Well, I will start discussing about subnetting in details. To understand subnetting, let me tell you that the entire IP addressing is classified into two types. One is called classful addressing, and another one is called classless IP addressing, which is CIDR, the concept of CIDR, VLSM, and all. Now, when we start talking about classful addressing, we have seen there are 5 classes: class A, class B, class C, class D, class E. And when we have seen the subnet mask, what is subnet mask? Subnet mask is, it identifies the network portion and host portion. Since in class A it is 8-bit is in host, 8-bit is in network, and remaining 24-bit in host. In class B it is 16 plus 16, and class D and E is not required here because this is for multicasting and future use. Now in class C it is 24-bit and 8-bit. Now it is very much rigid. Class A, when I design a class A address, I need to take a range of, I need to take a host of 2 to the power 24 minus 2, a block size of 2 to the power 24. And why I should take a host or a host bit of 24 and host bit of 16 and host bit of 8 always? Okay, so in case of classful addressing, the subnet mask is fixed. It is called fixed length subnet mask. So in class C it is 255.0.0.0. Class B it is 255.255.0.0, and it is class C 255.255.255.0. So how many bits are there in network? All bits set to 1, and the bits which are in host set to 0. And that is how we calculate. Now in a classful addressing, that rigidity is there. What is the rigidity? That you should have it. You should take a block size of 24 in case of class A. You should take a block size of 16 in case of class B, and you should take a block size of 8 in case of class C. Now there is a little one more little constraint there in selecting IP addressing, that in IP addresses the block size should be in order of 2 to the power n, means it has to be 2 to the power, here in this case when it is class C it has to be 2 to the power 8. In case of class B it has to be 2 to the power 16. In class of A it is 2 to the power 24. This is number of host. This is number of or I will not say number of block, it is block size. I will say it is block size, and number will be 2 to the power n minus 2. So it has to be 2 to the power number of host, it will be 2 to the power 8 minus 2 to the power 16 minus 2 to the power 2 to the power 16 minus 2 to the power 24 minus 2. So that is the major problem, that why should I go for a fixed length? I may require a block size of 2 to the power 4. So for that, there is a concept of classless IP addressing. The classless IP addressing, there is a concept of CIDR and VLSM, that's classful interdomain routing, the full form of CIDR, and VLSM is variable length subnet mask. So the variable length subnet mask is actually telling me how to calculate a variable size host, but it has to be there are a few golden rules and formula. Let me tell you the formula. Whenever we calculate, we have to take a block size which is 2 to the power n. So n, which is number of host has to be maximum of 2 to the power n minus 2, where n equal to host bit. So 32 minus n is network bit. That means I can go for any number of hosts. So n can be 4. So if I take n equal to 4, so 2 to the power 4 minus 2, so I will be taking a 40 number of hosts. So 32 minus 4, that is 28 bit. 28 bit is my network bit. Okay, so I have to calculate subnet mask accordingly. Okay, so if it was 24 bit, the subnet mask was 255.255.255.0. So how to calculate a variable length subnet mask VLSM when this is 28 bit? I am giving you a table which will help you to calculate subnet mask VLSM quite easily. Okay, let me tell you where from I have derived this particular table. Then you can understand it better, that how to calculate the same. Okay, so here in this case, this is the number of hosts what I was talking about. So let's understand, or let's get a clear view about the entire 8 bit. Okay, the first value of the first bit is 128, next bit is 64, then it is 32, then it is 16, then it is 8, then it is 4, then it is 2, then it is 1. So that is how the entire 8 bit is. So the rule says if I have 28 bit, if I have, for example, 24 bit in network and remaining 8 bit in host, so this entire 24 bit network bit will be 1 and host bit will be 0. So there is a table to calculate it. Okay, so I have derived from here. Okay, 128, 64, 32, 16, 84, 4. Okay, so if first bit set to 1 and remaining all bit set to 0, the value is 128. So that means 1 bit means 128. So if it is 2 bit, then what will be the value? Then it will be 128 plus 64. So in that similar fashion, in this particular fashion, I have devised a mechanism by which you can calculate it very easily. Okay, so for example, I'm giving you a table. For example, if it is 28 bit, okay, the host is if it is 28 bit, how to calculate? Okay, so you have to take in the 28 bit, okay, you have to split it in 4 blocks. That means if it is 28 bit, that means it is 8 plus 8 plus 8 plus 8 plus 4. So this block 8 bit set to 1, 8 bit set to 1, 8 bit set to 1, and 4 bit set to 1. Remaining 4 bit has to be 0. So first bit, if it is set to 1, it is 128. Second bit, it is 192. Third bit, it is 224. If it is fourth bit, it has to be 240. If it is fifth bit, it has to be 248. 6, 252. 7, 254. 8, 255. So then I can find out this has to be 255.255.255.240. Okay, so there is a magic number. 256 minus 240 is actually 16. That is the block size, number of hosts. Now already you have seen, if it is 28, so 28 plus 4 is 32, so total is 32. So if this is host, sorry, this is network block, this is then host block. So host block 2 to the power 4 is nothing but my 16, so I got a magic number. Okay, so 256 minus 240 is 16, so that is a block size. So that is how we can calculate. Let me take one more example and elaborately tell you that. Okay, now how to write in CIDR notation. Always we, in case of CIDR notation, we mention how many bit set to 1, that means how many bits are there in network. For example, if I write slash 19, okay, that means 19 bit is in network, 32 minus 19, that is 13 bit is in host. So how many, n equal to maximum size will be 2 to the power 13 minus 2. Okay, if it is 2 to the power 13 minus 2, then I can calculate how many, what is the size of n. This is my block size, 2 to the power 13. Now 19 I have to split in this way: 8 plus 8 6, 16 plus 3 19 plus 0. So that means subnet mask will be 255.255.3 means 224.0. okay, so there is a I was showing a class C address previously. Now there is an easy way to calculate 256 minus 224, that means it is 32. So it has to be block size of 32 in this particular block, and it has to be, so it will be 2 to the power 8 plus 2 to the power 5. So 2 to the power 13 we can write 2 to the power 5 2 to the power 5 dot 2 to the power 8. So 5 plus 8 equal to 13. So 2 to the power 5 here and 2 to the power 8 here. So 2 to the power 5 means 32, that is a block size. So 32 into 256. So 2 to the power 8 is nothing but my 256. So that is how it is calculated. Okay. So next class we will discuss much more into details how we can do subnetting. For example, if I write 192.168.1.0/24, this is a clear case of classful addressing. If I have this kind of addressing, I can write